Question number 2. Let's follow this along. We're given the parent function, which is already graphed, and we're given the new function g. The question is, what are the transformations to go to function g? So how is the parent function changing? And then we're going to find the equation and then graph it. First part, class, let's take a look at this table, and we'll see it. The outputs go 1, 0, and then 1. So right in between these two, class, this is where our vertex has to be. It's in between the two exact same output points, or output values of 1. So there is our vertex. So we've got our vertex at -1, 0. Remember, class, if we look at our vertex here, the h value is always the x value, which moves left and right. The k value is our y value, which moves up or down. Let's go ahead and write this out. H equals -1, k equals 0. All we're looking for now is the a value. Let's take a look at A. So we're going to go to our vertex again, and we're going to say, okay, we're going to go 1 to the left or 1 to the right. It makes no difference on our x-axis. The row above the vertex, the row below. How do we get to the output from 0 to 1? And you can see, class, we are adding 1 here, and that is our a value. So our a value here is 1. Same shape as the parent function, which is also 1. So let's go ahead and write our final equation. G of x equals a times x. Let's make that an equal so you don't see that as a minus. Equals x. Now we always switch the sign because the -1 tells us we are moving to the left. And that means in our equation, we're going to see that as an opposite sign. So that's going to be +1, always the opposite sign. There's our squared. And then our k value, we'll just go ahead and write this down, +0. I noticed I had a little mark here. Let's clear that up. All right, +0. And then again, class, you'll get credit for this if you write the function this way. This is correctly written, but we can see we can simplify this. We can write g of x equals, the 1 is not necessary because it's multiplying. We've got x plus 1 squared, and then the k value doesn't have to be written because +0 does not change our equation. Let's go ahead and graph that now. Again, I'll try to graph these individual points one at a time. Let's see, we'll go with light blue again. So we got -2 and 1. And then we've got -1 and 0. And then 0 and 1. 1 and 4. And 2 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Got it. Now, class, the reason that we find the line of symmetry is this will make it easy for us to actually graph the other points that we can't see on the left side. Let's draw our line of symmetry right now. And that's going to go right through the new vertex. Boom, right there. And now you can see, class, that we can actually reflect these points. So this one here is already reflected. This is 2 away from the line of symmetry, so 2 to the left. This is 3 to the right of the line of symmetry, 3 to the left. And now, connect those points together, draw some arrows on the top, and you have your transformed parabola, which makes sense, class. The k value is 0, so it doesn't move up or down. The h value is -1. That means our graph is actually moving to the left.